All right, good morning, everybody. Today's an asynchronous lesson going over some basic probability terminology and rules. Let's get started. So first, some terminology. These all refer to a random event, which can be something we traditionally accept as random, like rolling dice, choosing a card, but also can be more non sort of traditional things like picking a person who and finding out what soda they like, or choosing an M&M for a package. Um, so those are just like a random event. We can really make it be anything. So first, an outcome is just something that can happen. An event is some outcome or collection of outcomes. Can be one, can be more than one thing. Our sample space is all possible outcomes. When we refer to something as mutually exclusive or disjoint, these are two events that cannot happen at the same time. And we use either of those two words. There's no overlap. They can't both be true at one time. And then the complement is everything in the sample space except that one event. It's like the not. So some basic rules, and if you want this guide, you can go to, there is a Google Doc. You can either print it or fill it out there if you want to have a record of this. So the total probability, the probability of all events in a sample space S is 1. I was going to write that symbolically. All right, P parentheses S equals 1. The probability of S, the sample space, equals 1. So the probability of an event any event is always between 0 and 1. Let's look at an example. If we let A be the event of drawing a heart from a deck of cards, say the probability of A equals 0.25. And notice that's P parentheses A equals 0.25. The probability of equally likely events, this is the most simple case. If all outcomes are equally likely, so everything in my sample space, the probability of an event is the number of outcomes in that event A divided by the number of outcomes in the sample space. So let's go back to A being the event of drawing a heart from the deck of cards. Well, how many hearts are there in a deck? There's 13. So there's 13 of those hearts, those cards, and then there are 52 cards. So all I have to do is just divide 13 divided by 52, which is where I got that 0.25 from. The complement rule is the probability of A not happening. And I take 1, my entire sample space, and subtract A. So I can say the probability of not A, and I put that in the symbols. I could also say the probability of, so I can say probability of not A. I can also write probability of A and then a little superscript C. That means A complement or not A. Those things mean the same thing. And that is 1 minus 0.25, which equals 0.75. Hopefully that's pretty intuitive. Let's look at we're going to put in an additional event. Let's look at the example. If B is drawing a club, so say I have a deck of cards, 52 cards, and drawing a club. A and B are mutually exclusive, right? The one card I draw, it can't be a club and a heart. So those two events, A and B, if I'm drawing one card, are mutually exclusive. So the probability of A or B, I can just add 0.25 plus 0.25 equals 0.5. Again, hopefully this is kind of intuitive. Something to know about probability, it uses the it is like sort of like distilled logic, and actually it is the language of logic. And so most probability questions, really most if not all, can be answered using logic, but you just have to go kind of carefully, and we're going to kind of practice using this logic and using this language. So let's add in one more kind of event. So event C is I'm drawing one card and let that C be drawing a king. So now if I want to look at probability of A or C, it's a little more complicated because they do have an overlap, right? There is a king of hearts. So when I add, there are 13 hearts and there are 4 kings, but there's one that's kind of an overlap. So I have to make sure I sort of subtract away that overlap. Otherwise, I'll get a probability that's too big. So there's 13 hearts plus out of 52 plus 4 kings out of 52. I subtract away that king of hearts that otherwise I count it twice. and my ending probability is 16 over 52, which when I divide, I get 0.31. Either one is acceptable for me, by the way, whether it's a fraction or a decimal. Okay, and if I was to use symbols, right, the probability of A or C, I take the probability of A plus the probability of C, and then I subtract the overlap, the probability of A and C, because there is an overlap. In the example above, there was no overlap because I can't have a club and a heart, but I can have a king and a heart. All right, so let's look at just sort of a very simple, example. So below here are results from the 2000 AP Statistics exam. Is it a legitimate probability model? How do you know? So the thing to check when you're checking to see is if it's a legitimate probability model if they all add to 1. I add them all up. 0.146 plus 0.212 plus 249 plus 1.59 or 0.159 plus 0.234, and it equals 1. So it's legitimate. The percentages also, that's equivalent to 100%. So whether you do decimals or percentages, they're equivalent. All right, let's look at the next example. Are the events getting a 4 and getting a 5 mutually exclusive or disjoint? And how do you know? So if I look at 4 and 5, they are mutually exclusive because a randomly chosen person, you can't get a 4 and a 5 at the same time. Again, if I'm thinking of my really my random event is choosing one of these people who took this exam. So if I define the event of passing as getting a 3 or above, what is the probability of passing? So if I look at 3, 4, 5, we talked about how really these scores should be mutually exclusive, so I can just add them. 0.146, 0.212, 0.249, because 3 or above means a 3 or a 4 or a 5. The word or is always adding, so I add these up, and I get 0.607. So the probability of randomly choosing a passing student on the 2018 AP Stats test is 60.7%. One more example. What's the probability of not passing? There are 2 ways to get this, but we'll go ahead. We already did some. I'm going to go the shorter path. I could add the 2 and the 1. We'll do this the complement rule way. The probability of not passing, I calculated passing was 0.067. So not passing complement is 1 minus 0.607. So I subtract and I get 0.393. So the probability of randomly choosing a not passing student on the 2018 AP Stats test is 39.3%. All right, this is a preview. So we looked at kind of the simplest case, and that's all we're going to be covering today. But here is a more complicated one. If I have a certain group and 50% like Pepsi, 30% like 7-Up, and 10% like both. So this problem has events that are not mutually exclusive. To consider these more complicated situations, we'll look at a Venn diagram and 2-way tables. That'll be coming up next class. All right, everybody, have a great day, and I will, good luck.